Hey everybody, and welcome to a video on probability as objective chance. This video follows up on the last video where we started looking at different interpretations of probability. The interpretation that we've been working with through most of the course is probability as reasonable degree of belief, or at least implicitly that's been the general concept of probability that we've had. In the last video we saw that probability can also be viewed as relative frequency. In this video we're going to look at yet a third interpretation of probability. So chance, like epistemic probability, is going to be defined over statements, right, or propositions. Now, whether it could be defined over arbitrary statements or only over a special class of statements is something that we won't really focus on much in this class. Rather, we'll just focus on sort of illustrating the sort of propositions that we definitely want to assign chances to through some examples. Right? So, for example, we want to be able to say things like the chance of a coin landing heads is 1/2, right? In general, we want to be able to talk about the chances occurring in various gambling contexts, right? If I spin the wheel of fortune, the chance of it landing on bankrupt is 10% or whatever it is. Right? Chance also comes up a lot in physics, right? So we might want to say that the chance of a particular sort of atom decaying within a given year is, say, 30%. Or in quantum mechanics, you might consider the chance that a particular measurement of a particle's position maybe turns out in a particular way. We could think then in general, right, of the chance of a statement sort of as the objective propensity of the statement to be true given the laws of physics, right? Now, this isn't the only interpretation of chance we could take. It's not necessarily even the best one, but it's probably the most intuitive way to introduce it. So that's how we'll think of it here. So in this class, we're going to view chance as attaching to propositions or to statements, right? Statements. And I'll write, in general, write CH of X as the chance, right? This is, right, the chance of a statement X. Right? And I might write things like the chance of X equals little r, right? And this will mean, right, that the chance of proposition X is equal to r. Now, when thinking about chance, it's really useful to highlight its connection with probability understood as rational degree of belief. And the connection between these two notions is codified in a famous principle that was originally defended by philosopher David Lewis, known as the principal principle. The principle. And he called it this because he thought it basically characterized the most important feature of chance. So to understand this principle, let's consider the following case. Let's suppose that we have a coin that we're going to flip, and let's say that little h, is the proposition that the coin is going to land heads, and we'll say right then not h is the proposition that it's going to land tails, right? Now let's suppose we don't know much at all, except we're told that the chance that this coin is going to land heads is equal to 1/2. So there's a 1/2 chance of the coin landing heads. Now we can ask a question, right? What should our probability, right? If I use P to represent our epistemic probability in H, right? What should our epistemic probability in H be, given that we know that the chance of H is 1/2, right? What should it be, right? Now, there's a very intuitive answer here, right? It's probably leaping out to you, right? 1/2, clearly, right? If all we know about the coin is that it has chance 1/2 of landing heads, then we should believe it that it's going to land heads to degree 1/2, right? This rational belief should defer to objective chance, right? So in this case, right, we'd say this should equal 1/2, right? This suggests a sort of general principle, right? which is that for any proposition x, right, given or conditional upon the chance of x being equal to some number r, my degree of belief in x should be r. Right? This you might think should hold for all propositions x. Right? Now, that's good so far as it goes, right? But oftentimes we have more information available to us than just the chance of a particular proposition. So, right, for example, right, I might know in this case, right, how the coin landed the last time it was tossed. Like maybe I know it landed heads last time it was tossed. Or maybe I know something about the factory where the coin was made, right? I may just know a bunch more information, right? Now I can let's let E be the proposition that I don't know, that captures all the other information I have about the coin. Like for example, right, the coin landed heads last time. It was made in factory F, right, etc. Right, this sort of information I know about the past of the coin. Right, now, right, I can ask another question, right, which is, right, what should be my probability, my epistemic probability in the coin landing heads, given this information E, and that the chance of heads is still 1/2, right? Here again, right, there's an intuitive answer, right? It should be 1/2 again, right? This proposition E, right, might provide evidence about whether or not H is true. That's about whether or not the coin will land heads. But it does so only by way of influencing my beliefs about the chances of the coin, right, landing heads. Once I fix what the chance of the coin landing heads is, the E makes no more difference to my degree of belief about the coin landing heads, right? Rational degree of belief not only defers to chances, but chance information, in a sense, takes precedence over other sorts of information, at least to a limit, right? So this then suggests, again, a more general principle that probability of any proposition X, given some information E, and given a statement of the chance of that proposition, right, should be equal to the chance of the proposition, right? For all X and E, right, propositions. Now, this, as stated, is going to be too strong, right? Because even if chance information takes precedence over information, there's limits to that, right? So, for example, right, suppose that right, X was actually equal to E. So actually, I conditioned on the event or proposition X itself, right? Then, of course, probabilistic coherence would force me to have a degree of belief 1, right, in X conditional upon X and the chance of X being R, even if R is not itself equal to 1, right? So this can't hold in full generality, right? So what David Lewis says, right, is that it holds for all X and all admissible E, right? Admissible. So basically, the proposition is going to be admissible just in case it only gives you information for proposition X by way of giving you information about the chance of X, right? If it gives you any information at all. In the examples in this class, we'll generally assume that the evidence propositions we condition on are admissible in the sense that they allow reasonable deference to chance, all right? Right. Now, I want to highlight one further thing, which is, what if you're unsure about what the chances of a particular proposition are? So let's consider again that case where we're going to flip the coin. But let's say I don't know what the chance of the coin landing heads is, right? But let's suppose that I know it has some chance, and I have it narrowed down maybe to a couple of possibilities. Let's say maybe I know either that the chance of coin landing heads is equal to 2/3, or, right, that the chance of the coin landing heads is equal to 1/3, right? So I know it's either 2/3 bias towards heads or 2/3 bias towards tails. Does the principal constrain what my epistemic probability in the proposition H is, right? It does, in fact, right? Because, right, if I know, right, that one of these two chance hypotheses is true, either the chance of heads is 2/3 or the chance of heads is 1/3, right, then I can do the law of total probability together with general conjunction rule, and I can actually write this out as probability of heads is equal to the probability of heads given the first chance hypothesis, namely that the chance is 2/3, times the probability of that hypothesis being true is 2/3, plus, right, the probability of the other case, right, the probability that it's heads given that the chance is only 1/3, times the prior probability of that chance, right? Chance of heads equals 1/3. All right. So, right, this is just the laws of total probability derived from the probability axiom, together with general conjunction rule, forces this to be the case. Now, the principal tells me what these conditional probabilities have to be, right? Now, the first one, the probability of h given that the chance of h is 2/3, has to be equal to 2/3. Right? So I get 2/3 times the probability that the chance of heads is actually 2/3, plus 1/3, right? Because we get the probability that heads, given the chance of heads is 1/3, it's going to be 1/3, times the probability that chance of heads is in fact 1/3. Right? So, right, this now follows from the principle together with the probability axioms that my degree of belief in the coin landing heads has to be an average of the different possible chances, right? Or the different chances that I think are possible, where the weights are fixed by my degree of belief in those chances being the true chances, right? So in general, then, we could say that the principle forces it to be the case that my degree of belief in any proposition about which I'm certain there's some objective chance to it has to be my epistemic expectation of the objective chance of that proposition. So in general, we'd have for any proposition X about which we're certain that there's some objective chance assigned to it, I would say that its probability has to be equal to a sum over I of the probability that the chance of X is equal to I, right, times the chance itself, right, which in this case is I, right. Now this formula with the sum and everything, it assumes that there's only finitely many different chance hypotheses that I think are possible, although we could generalize this to infinite cases too. All right, so that's one consequence of the principle, which relates probability as rational degree of belief to probability as objective chance. On Monday, we're going to look at more connections between probability as objective chance and probability as relative frequency, and tie those together also with probability as rational degree of belief. So we'll see how all three fit together in interesting ways. All right, so we'll have that to look forward to. Please remember to complete the participation poll for this video, and I'll see you guys next time. Thanks a lot.